Hi and welcome to my maths class. Today we're going to try and prove that the opposite sides and angles of a parallelogram are equal. Now remembering from my previous work, I told you the information they give you, you cannot use to say, oh, but I know that the opposite sides are equal and the opposite angles are equal, so yes, it's a parallelogram. You can't use those two qualities. What you can use is any other qualities. Now you know that a parallelogram, the opposite sides are parallel. That is by far the most easiest one to use. Okay. Now if I know that they are parallel, what information can they give me that will prove that the sides are equal and the angles are equal? Now let's work with the triangles again. This is where your congruency comes in again. Right. In triangle DEF. So we got triangle DEF and we've got triangle GEF. In triangle DEF and triangle GEF, what do we have? If this is an alternate angle, why? We know they're parallel. So if they're parallel, I can say that F2 is equal to E1. Why? They are alternate angles. I know that because DF is parallel to EG. Then I have the second angle. Why? Because if I take my parallel line, let's do it this way. Can you see the Z? So I have that E2 is equal to F1. Again, alternate angles, but a slightly different parallel line. It is DE is parallel to FG. Then I have a common side. FE is equal to FE. It is common. It's in both the triangles. Therefore, the two triangles are congruent to each other. And my reason is side, angle, angle. I've been given two angles and a side that's equal. Now remember we said when you prove that two triangles are congruent, immediately they have three sides and three angles that are equal. Now we've got that the two angles are equal, right? We've already proving that. So the remaining angles have to be equal. Therefore, D is equal to G, right? But also, if you look, that would mean if E1 was equal to F2 and E2 was equal to F1, then I can say that angle E is equal to angle F. Okay, now from the congruency, we've now proven that the three angles are equal. Now what do we do about the sides? We've got that EF is equal to EF. That's one side. If we're working with F2 and E1, then I can say from my congruency that DE is equal to FG. And if I'm working with E2 and F1, then I can say that DF is equal to EG. Now look at what we have. We have that the opposite angles are equal, which is what they had asked. And then we have that the opposite sides are equal, which is again what they asked. So we've now answered their question without saying it or without just randomly agreeing. We had used a proof that does not include that. We had used some other property of the parallelogram. In this case, we had used the parallel lines, and then we had proved that the other fact is true. Thank you for watching.